point, I'm glad to announce this year's keynote speaker. Yeah, there he is, Dr. Jochen Papenbrock. He's head of financial technology, EMEA at NVIDIA. And I'm very happy that you made it, Jochen. We know each other for quite a while. I think we first met 15 years ago. He's one of the most advanced quant guys I know. So he has a background, engineering background from KIT, Karlsruhe Institute of Technology. And he was a consultant to institutional investors. And someday he joined a small company, and the name was NVIDIA. And one can argue about correlation or causation, yeah? But when you joined, NVIDIA took off. So I have the strong impression that there's some link between you and the stock price. And I'm really glad that you will give us a keynote on Agentic AI and AI factories transforming financial information services. There we go. Over to you. Thank you.
Thank you, Alexis. Yeah, thank you very much for inviting me, and I think it's really something different, correlation, causation, so I'm not the reason. So today I would like to talk a little bit about Agentic AI, which is a buzzword, or is it more? I think it's more, and I would like to convince you today that Agentic AI is not only the future, it's already here. And it's very connected to our industry. Financial data and AI is converging. And I will show you if the flipper works. Yeah, it does. So, AI agents. We have so many people on this planet that could leverage and benefit from using agents. Agents are digital employees, if you want. So think about the IT department in your organizations. It's basically an HR department for digital employees in the future. So those digital employees will work together, those agents, but also humans will interact with these agents and work with them. So for example, if you have 1 billion knowledge workers, there will be maybe 10 billion AI agents that support those knowledge workers in the future. Or think about those software development people around the planet, 30 million, they can use AI and agents to build the software, or let AI help them build the software. 50 million call center agents and so forth. A lot of research scientists, IT professionals, creators of content globally, they will benefit from Agentic AI. So that's why I believe it's a huge business. And it's important for our industry to understand how to leverage this technology and how to build an infrastructure to run Agentic AI in your own enterprises, to produce new services, new products, to serve the customers in a very different way, to automate in a very different way, and to generate code. Nobody needs to code anymore. AI agents will help us do that job. So in the past years, we were talking about use cases in AI. What's a useful use case? What's the value of AI use cases? And first of all, we were talking about machine learning, about predictive AI, predicting imagery, for example. And then we had, with the arrival of ChatGPT, an iPhone moment of AI. So generative AI was able to generate answers and to process human language in almost no time. Think about financial reports, financial news, natural language processing, or audio transcripts. So those are typical use cases for natural language processing. But now with Agentic AI, we have outcomes that can be generated, real value coming out of this. And those agents, to create them at scale, at enterprise scale, we need a different kind of infrastructure. We need AI factories. An AI factory is basically some factory that has an input, which is data and energy. And on top of this, we generate tokens or intelligence. That's the output. So a good factory would maximize the throughput, the tokens, based on the given energy budget and the given data. We are limited by energy, obviously. So the more intelligence we can get out of our factories, the better. And this is what's happening everywhere around the globe. AI factories in all industries, manufacturing, healthcare, transportation, drug discovery. So it's for manufacturing intelligence with your own data. And it's for intelligence in the form of digital tokens, and there are new opportunities in all these industries. Now talking about the equipment of those AI factories, how do we need to build those? I talked to some people in Frankfurt on a board, on a panel, and some claimed that Frankfurt could be like the AI capital of Europe because there are so many data centers there. But it's not true, because those data centers are not ready for AI. They are traditional data centers that crunch a lot of data, but are not able to train large models or run huge amount of AI agents. So we need to transform our data centers to become AI data centers. How do we do this? So in the past, we relied 20, 30, 40 years on a compute model based on CPUs. CPUs is what everyone has in their notebook. It's the standard chip. It's a great tool. NVIDIA built CPUs themselves, but it doesn't help us because, as you can see, there's a plateau in the performance. So CPUs can't be accelerated anymore. There's a physical limit to them, but the amount of data and the size of models is growing, obviously. So CPUs is not the right compute model going forward. So we need to think about accelerated computing that's able to run data processing massively parallel. It saves a lot of energy doing that. And here you can see that that's the only compute model that can handle the future workloads, actually. Just to give an example, here's a workload, for example, training a model, customizing a model, or doing reasoning with a model. Think about DeepSeek. DeepSeek model is a reasoning model. So on a CPU, this would take 101 hours, for example, T 1 hour. If you now add the GPU, the graphics processing unit, you will see that the workload is reduced to the time to process to 1 hour, and this saves 98% of the dollars spent and 90% of the energy. So accelerated computing is also sustainable computing. We can't handle all these AI workloads with traditional CPU-based data centers. So this is what NVIDIA is actually doing. There are many other companies doing these things. NVIDIA is one example. So we see here basically the interior of this infrastructure that we need for building those agent factories. It's all about GPUs, about chips, but also the networking. So you need to think about how to network these GPUs because there are thousands of them in one data center. So that this data center acts as one giant GPU because those models have become so large. So for example, OpenAI, ChatGPT was trained on such a machine. But people can now access these AI factories in the public cloud everywhere with a few clicks. It's available in Azure, on Google, Microsoft, and so forth, AWS. And what's also important in this picture is the software layer. We need a software that's programmable because nobody wants to run such a factory without knowing how to build that, how to operate agents on it. So we need a software layer, and this is what we call full-stack AI factory. And the good news is this entire full-stack AI factory is enough to build agentic systems, to run agents, and it's also something that can be installed in companies, inside those companies. It doesn't have to be in US hyperscaler clouds. It can be regional, and we see national or regional sovereign AI projects, for example, in Italy, in Switzerland, in Paris, in Denmark, Germany, maybe also in the future, let's see. So nations can build their own AI factories. They can keep the model, they can keep the data inside their region. Don't have to send it to another place. Sovereign AI is a big topic. And also some companies, for example, German Finanzinformatik has built an own GPU cluster in their own data center, which is really safe and secure because no data leaves your own data center, and you can do all this AI in your own data center and fine-tune your models. It's all about fine-tuning AI models, connecting agents to your own corporate data because that gives individual value. Because you have individual data that's only in your enterprise, and how do you create the value? You need to insert it or combine it with agentic AI to make it accessible to humans that just need to type on their keyboard, and they can interact with this data in real time. So AI and data goes hand in hand, and we need to think about how to access agentic AI and how to build sovereign AI factories. The software layer, really important. So inferencing, that's a new buzzword. Inferencing means running the model, right? Huge models need to be run. That's also something that needs to be done by accelerated computing. And there are a lot of open source models out there. You might have heard about Llama models or Mistral models from Europe, from Paris. And for example, running these models with an optimized inference platform, as we see here, further accelerates the workload, and you can increase the token size. Think about the AI factory, which is measured by how many tokens can I generate per energy unit. So here, the acceleration doesn't only come from accelerated computing, but also from a good software that runs and creates more tokens. So just by using that software on Llama, an open source model, you can accelerate by a factor of 2.6x. It's not percent, it's x, right? More throughput, more users. So the more users you can serve with a single GPU, the more efficient that is. So we need to think about not only manufacturing intelligence, but producing AI at enterprise scale, at industrial scale, where we optimize every step. Small models running, orchestrated, and inferenced at no time with very low latency. Very important, obviously, in financial service industry. Now comes another workload for GPUs, not only training models or fine-tuning, customizing models and building these RAG pipelines. RAG pipelines means connecting AI models to your own corporate data via retrieval augmented generation. But rather, now we also have reasoning models, which is, for example, DeepSeek is one representative. NVIDIA has also built models based on the Llama family, open source models that can do reasoning. That means thinking longer and planning and using critique to improve the system so you can create a data and AI flywheel. So reasoning models are very important for building advanced agents that can do even more tasks autonomously, because reasoning models, they can do contextual understanding. They can combine multiple data sources. Think about combining in a time series manner or fashion order book data and also financial news, which is unstructured data, right? Combining those sources in an AI time series factory manner is going to be very useful and valuable. So, AI scaling laws. We have many AI scaling laws. The first one we have observed with like ChatGPT and the arrival of open source models like Llama. That was the pre-trained scaling. So we use compute to train a foundational model. Everybody can download that and fine-tune and make it your own financial.com Llama, for example. Yeah? And then comes the post-trained scaling. That means you take this model, fine-tune that, and connect it to your corporate data. Now comes the third scaling law, which is the test time scaling. That means having a model that can think longer and create more intelligent answers, instead of a one-shot output, as most of the AI models do. So we have test time scaling, 3-time scaling laws. And as you see, intelligence of those models and usefulness and creating value is increasing, but also is the compute power. And I'm referring here to the keynote by Jensen, who said in the last keynote, this is what the world got wrong when DeepSeek arrived, a reasoning model, that they thought there will be less utilization of GPU consumption. It's the contrary, actually, because those models need more thinking, test time scaling, and you need compute, obviously, to make these AI agents think longer to fulfill more advanced tasks. So just to give you an example, and everybody can try, so this is no theory here, this is really practice. So if you want, you can play around with these models on build.nvidia.com, for example, or on Hugging Face, or any other place where you can download these open source models. And one of these models is the Llama Nemotron, as I said. So based on the open source foundational Llama model, we were able to make this model a reasoning model. So we gave those model a lot of reasoning tasks, math tasks, statistical tasks, and we trained and got feedback a lot of times. In the end, this model was able to reason just like a DeepSeek model. So you can just download that model and run it wherever you want. That means you can run it air-gapped in your own environment, which is super secure and sovereign, or you can run it in your local cloud or in the public cloud. And these models are really leading accuracy, highest efficiency. If we compare to DeepSeek, for example, there's even more reasoning quality behind it, but the model size is half the size of the DeepSeek. Smaller model means much less energy consumption, less GPU consumption, just much cheaper. Think about the efficiency of the AI factory, what that means, right? And also, reasoning is not needed all the time. What's the capital of Germany? What's the capital of France? These questions, you don't need reasoning. You can switch it off, right? You can save resources. Only few sort of jobs that you ask the system to do is reasoning on, right? It's another factor where we save energy and time. So what do you need to build an AI blueprint or an agentic AI environment? Basically, three things. First of all, you need to build a NeMo retriever example here, which is sort of an AI agent that connects to your data sets, right? Connecting to other agents, connecting to data sets, connecting to tools. And the retrieval augmented generation, as I just mentioned, is a way to make your company unique because you have unique data. And with retrieval augmented generation, you can connect to this data and interact and talk with this data and connect to different data sources. Then, and I talked about it, you need a good reasoning model. It could be the Llama, it could be a DeepSeek or any other of those models that are now popping up in the open source world. And you need, of course, toolkits that help you orchestrate these agents. It's like an onboarding of a new digital employee. You need to train them, you need to monitor them, to measure the performance and see how they connect with other agents and human employees. So think about HR department being the, or IT department being the HR2 department in the future. So you need to have tools, and we have provided open source tools here with the community that help you evaluate your agentic AI system and to gradually increase the quality of those models and reduce hallucination so that it can be used in a trustful way in production. And here's another demo which will soon be available. It's the AIQ blueprint. So that's also just downloadable. You get this sort of architecture. You can build your own AI agents to help you build a research and reporting assistant in a few clicks. So it's really no future. Future is here, I would say. And it uses open source models. So everybody can run this, getting access to GPUs wherever, in your own data center or in the public cloud, and then you can build your own research assistant where you can, on the fly, build agentic systems, connect to your data sets, to different data sources, actually, and then interact with that system and ask very complex questions that the system will be able to answer. And it's your system. You have the control of the model, the data, the quality. It's different than using an API model like ChatGPT. ChatGPT is a very nice tool to get started in AI, but it's not your model, right? You send data, you use that model, it's someone else's model, right? Or Gemini or any of these API-based models. They have their position, I think, in the AI value chain, but in terms of sovereignty and control over AI and making these your own AI models and agentic systems, I think we should also consider using open source models that run in your own environment, right? It doesn't sound that complicated. There are many people who can train others using this, and as you see, this is a few clicks. So NVIDIA really made this sort of democratized. They democratized agentic AI, and we put the easy button to supercomputing, AI factories, agentic systems, so you can start today running these things. And there are a lot of examples doing those. For example, in the US, BlackRock, Capital One, NASDAQ. So they are all using these kind of technologies and presented at our GPU technology conference, which is rather a gathering of the entire AI industry with 25,000 people attending and 300 AI companies gathering, presenting to each other what's the latest and greatest in AI and how can I leverage this in financial data science and financial services. Examples from Germany and or from Europe is really happy that we have these examples now. UBS, BNP, Finanzinformatik, I already mentioned. So more and more European banks we see on the stage, and they also start leveraging agentic AI and start building own models, sovereign AI, and using AI compute platforms to build their AI journey. And with this, I would like to highlight one interesting conference which is coming up in Paris in a few days. It's sort of the NVIDIA GTC conference for Europe, which is a remarkable signal, I believe. And the big brother, the GTC Global, as I mentioned, has all these AI companies join, and 25,000 people. It's not going to be that big here, but it's going to be a very exciting event where there, again, will also be financial service companies present the latest and greatest and how they leverage this technology that you have seen. So my recommendation would be test these things out, inform yourself about sovereign AI, open source models, and take over control of your AI and your AI journey. Thanks for your attention.
Thank you, Andrea.